Okay, so the system we have right here, it's a battery backup system. And the way it works, we can connect two models right here. We just connect the positive and the negative on one side, positive or negative on the other side, for this for one model and this for the other model. And this is goes through this disconnect switch to either activate or deactivate these connections. And model 1 corresponds to the charge controller, this charge controller, the MPPT one. And then the model 2 will correspond to this, will be connected to this pulse width modulation charge controller through these connections here. So model 1 for this MPPT charge controller, and model 2 for this pulse width modulation controller. Uh, with this um, with this more efficient charge controller, we're recharging this battery on the bottom, this lead acid battery that has 12 volts, 35 amps, and that battery is providing power to this pure sinusoidal 120 VAC inverter. So it gets the 12 volts out of the battery, and then it converts those 12 volts to 120 VAC signal. And so then this small battery on the side, this 12 volt, 12 amperes an hour battery, it's being recharged by this pulse width modulation charge controller. And this battery, it's providing power to this not sinusoidal um, inverter. So the inverter, what comes out of this is is not a 60 hertz signal, but it's a modified square wave signal that we can use to power on small appliances, but not like motors or more sophisticated equipment that needs frequency or that needs a certain frequency, like the frequency we have on the outlets, that it's 60 hertz, and which is produced by this pure sinusoidal inverter. From there, we also have this kilowatt meter to measure and calculate how much power we are consuming out of the inverter, which can only provide about 1,000 watts. From there, these charge controllers, one of these also has a two USB outputs there. You can charge your phone or other appliances. In this case, just for proof of concept, we are also charging this drone that actually works. And the control, as with other documentation related to this system, it's inside this box right here. Okay, so with nothing else to say, let's power this on. Okay, so once we're here, here is the box with the documentation. It is properly attached to this board with a Velcro tape so that it doesn't fall, and it's all on the side of the box, so it's very secure. And then here's the control for the drone and some documentation, as well as um, the sensor for the MPPT charge controller. And so once we're here, to power on the inverter, we do this connection here, and then this other connection here. Of course, it will create a spark, but it's safe. It's safe as long as we're using 12 volts, 35 amps, and not a higher voltage, right? And so once you have your inverter connected to the battery, from this button here, you can either power on the inverter directly, or if it's off and you select this other option here on the side, you can control it with the remote, which is this one. And we just power this on, and it turns on the inverter as well. And for this, for whenever we have this pure sinusoidal waveform inverter on, then we have this stack light here indicating that it is on. because well, we are getting this connection right here, and here we can, well, from here we can like take different readings, of course. And as you can see, we're consuming right now 0.13 amps, and out of the 1000 watts that we can get, we're only using about 6 watts. And so from here, from this connection right here, we go here to these block connectors, and we have all of these block connectors in parallel, creating a line connection, then the neutrals, and then the ground. And from there, we are able to power this power supply right here, which is a 24-volt DC power supply. From this power supply, then we power up these blocks right here. That eventually, like, we're only using one of the connectors there just to power the red light on the stack light. And also only this 120 VAC signal is grounded because it's high voltage, but for small voltages like this we don't need a ground connection. And for the models that we have down there, those are not very strong models, and we also don't need a ground connection. So mainly this ground connection here, this copper plate is just connected for this specific connections. And so now what we need to do, here also we have these connectors here. This will either activate or deactivate the charge that it's going to be flowing through the battery. And so as you can see, this connector here, this disconnect switch activates this MPPT charge controller, and we only have the battery, and we are sending power to the load. And in this case, our little load here is this fan that will help us to cool our batteries so that they don't get too hot in case we are getting too much power out of them. And we can activate or deactivate this by pressing enter. As you can see, the little arrow is stopped in there, and then our fan is stopped too. But if we press enter again, then we have the fan running here. And the similar goes for this one. Once we activate it from here, and we only have the battery, here notice we have the battery and the light bulb. If we press enter, then we have the little light bulb there, and our fan right here is going to start rotating. If we press enter again, then our fan stops rotating. Okay, so now what we need to do now is get the connections of the solar panels so that we can see when the batteries are getting charged. And so we just need to connect them here. And for this purpose, because there is no light outside, we're just going to pretend that this power supply right here is going to be the same as one of our solar panels down there. Okay, so you can see that we have the two lines connected there, positive to positive, negative to negative. And out of this power supply, we're getting about 15 volts, which will be like something similar that we will be getting with this model. And here, well, these are two models. We have two different models there, and then two connections there. The connections here are these connections here, so that it's very easy to hook these connections there on these block connectors. Okay, so now what we need to do, it's when we have this connected here and that we have the power, you can see there is no current. But as soon as I activate this disconnect switch, we turn it on, you see the solar panel here, that it's indicating that we are sending charge to the battery. And if you notice down here, we have a constant current here. We're just going to reduce it so that we don't damage our power supply, because it can only produce up to 500 500 milliamps, so I'm going to set it to 450 just for safety. And well, here you can see this, that what it's supposed to be, or solar panel is sending charge to the battery, and from the battery to the load, that it's this load right here. And we can always deactivate this load, and then if we click on select, we see that we're getting about 400 milliamps. If we click on select, we're getting 400 milliamps to the battery, which is correct to what we have in here. And here we're consuming about 13 amps, so that's, we're gaining more than what we are losing on the stack rate. So here we just change the connections from these connection blocks to these ones here, and it's the exact same process. So we turn this on, and then here our disconnect switch is on, and here you see that we have an error, but the reason we have an error there is because I connect these cables incorrectly, or and the reason they are connected incorrectly, I connect them on purpose because I messed up one of the connections on the solar panel here, and so I will highly recommend to measure voltage and then getting the right connections here, right? And so we power off this, and then